Okay, this is lesson 4.3 on solving inequalities, and specifically in this video we're going to talk about how to solve inequalities when you have to multiply or divide, because it's slightly different than if you just are solving and you use addition and subtraction. So I have a regular equation here, 3 equals 3, and we know that if I were to say add 2 to both sides of this, I would get 5 equals 5, and that is a true statement. And if I were to subtract 2 from both sides, I would get 1 equals 1. So if I had subtract 2 from both sides of 3, 3 minus 2 is 1, 3 minus 2 is 1, and that stayed true. Similarly, if I had taken 3 equals 3, and let's say I had multiplied both sides by 2. So if I had multiplied both sides by 2, I would get 6 equals 6, and that stayed true. If I had taken both sides of this equation and divided by 3, so 3 divided by 3 is 1, 3 divided by 3 is 1, that also stayed true. So when we have an equation, if whatever we do, multiply, subtract, divide, add, whatever we do to one side, if we do to the other, it will keep the equal sign. It'll keep it true in an equation. Same is not true with an inequality. So we're going to kind of explore that for a second. So I've got 5 is greater than 2. So I'm going to take that inequality, which is a true statement, 5 is greater than 2, and I'm going to go ahead and I'm going to multiply each side by 2. So I would get 10 is greater than 4. Is that true that 10 is greater than 4? Yep, that stayed true. Now I'm going to multiply each side by 3. So 5 times 3 is 15, 2 times 3 is 6. Is 15 greater than 6? Yep, that stayed true. Now I'm going to multiply each side by negative 1. So 5 times negative 1 is negative 5. And 2 times negative 1 is negative 2. Now, is that true that negative 5 is greater than negative 2? No, that's not true. So that actually is false. Okay, let's try this. What if I multiplied by negative 5? Well, I'd get negative 25 over here. 2 times negative 5 is negative 10. Is that true that negative 25 is greater than 10? Nope, that was false too. So these two right here, they seem to change our inequality. They both change our inequality. Let's look at what happens when we divide now. So let's say I divided each side by 10. Well, 5 divided by 10 is a half, and 2 divided by 10 is a fifth. So is that true that a half is greater than a fifth? Yep, that stayed true. How about now if I divide each side by 6? So that would be 5, 6, and 2 divided by 6 is a third. Is 5, 6 greater than a third? Yep, that stayed true also. Let's see here. Now I'm going to divide by negative 2. So 5 divided by negative 2 is negative 2.5. And 2 divided by negative 2 is negative 1. Is negative 2.5 greater than negative 1? No, that is not true. So that is false. Now I'm going to try this next one. If I divide each side by negative 8, 5 divided by negative 8, so that'd be negative 5/8. 2 divided by negative 8 is negative 1/4. Oops. Negative 1/4. Is negative 5/8 greater than negative 1/4? No, that's false also. So these two also change my inequality. So what do you notice about all of these? Well, in every single one of these, I'm either multiplying or dividing by a negative. So when you are solving inequalities, and you come up with something where you are multiplying and dividing by a negative, you have to remember that if you multiply or divide by a negative, you must flip the inequality to keep it true. So I'm going to let you go ahead and write that down. I'll give you some time to write that down. With an inequality, if you multiply or divide by a negative, you must flip the inequality. You can add or subtract. No problems, you don't have to flip the inequality, but if you multiply or divide by a negative, you must flip it. Now we're going to look at an example. Our first example, I'm going to bring this up right here, is z divided by 3 is greater than negative 2. Okay, so this is z divided by 3, so to solve this one, I'm going to have to multiply both sides by 3. Now, I'm not multiplying by a negative, so I do not have to flip the sign. So these cancel, and I've got z is greater than negative 6. Now, again, I have a negative 6 as my answer over here as part of my solution, but I don't flip the sign because I didn't multiply or divide by a negative. And I can check this again if I put it on my number line. And I have negative 6, one below is negative 7, one above is negative 5. Open circle at negative 6, and z is greater than negative 6, so I'm going to shade this way. And I can check to make sure this is right by using negative 5. So I'll put negative 5 in for z, so I get negative 5/3. Is that greater than negative 2? And yes, it is, so that is true. Because negative 5/3 is negative 1 2/3, which is greater than negative 2. So now go ahead and try the problems. I think there's 3 of them on page 213. Yeah, A, B, and C. Go ahead and try each of those, pause it, and come back and hit play when you're ready. Okay, let's go ahead and check these. So our first one was b over 4 is greater than a half. And so for this one, this is b divided by 4. I'm going to go ahead and multiply by 4 on both sides. The 4's cancel, and I get b is greater than 1/2 times 4 is 2. And again, if you put it on a number line, I'm going to put 2 right here, 1 and 3. You would have had an open circle at 2. B is greater than, so you should have shaded this way. So if I check 3, that would be, I would say, okay, is 3/4 greater than a half? And it is, so I know I did it right. Smiley face. Okay, so that was A. Let's go ahead and look at B now. Go like that. So here's B. B was d over 3. Is d over 3 greater than or equal to 5/6? So again, I'm going to multiply both sides by 3. And these cancel, and I get d is greater than or equal to, I didn't multiply by a negative, so my sign stays the same. Now this is like 3 over 1, so I do 5 times 3, which is 15, over 6. And that can be reduced. So we would end up with 12 and 12, 3, 6, which is, I don't know why I said 12. 2, and I was thinking 12 because 6 times 2 is 12. And 3, 6, which is a half. So d is greater than or equal to 2 1/2. And I'm not going to graph every single one of these, but if you graphed it, you should have a closed circle at 2 1/2 and shaded to the right, all the numbers greater than. And then C. So for C, you had y divided by 0.5 or half is less than or equal to negative 3. So I multiply by 0.5 on both sides, which is a half. So these cancel. And again, even though this negative 3 is negative, I didn't multiply by a negative, so I don't flip the sign. And negative 3 times 0.5 is negative 1.5. So again, with this one, I will go ahead and put it on a number line. I'll go 0, negative 1, negative 2. So I've got a closed circle at negative 1 1/2, and its y is less than, so I'd shade that way. Okay, so let's go ahead and look at some. So none of these we didn't actually have to flip the sign at all. So let's go ahead and look at one where we do have to flip the sign. So here I've got 3 is less than or equal to negative 3/5 x. So on this one, this is negative 3/5 times x. I'm going to multiply by the reciprocal. So on both sides, negative 5/3. These are going to be canceled because that'll just equal 1 when I multiply them. So you're left with x. Now since I multiplied by a negative, now I have to flip the sign, flip the inequality. This is 3 over 1. So remember, be careful. The negative you have to pick if you're going to put it with the numerator or the denominator. So I just put mine with the numerator. So negative 5 times 3 is negative 15. 3 times 1 is 3. Negative 15 divided by 3 is 5. And I read this always from the variable. So x is less than or equal to negative 5. So on a number line, I'd put negative 5, negative 6, negative 4. This time it's a closed circle at negative 5 because it could be negative 5. And x is less than or equal to negative 5, so I shade this way. So again, this would be a good one. Yeah, this is a good one that shows the example of how you have to flip the sign. Okay, so now I'd like you to try quick check 2 on page 213. There's 3 of them, A, B, and C. So go ahead and pause now, and then hit play when you're ready. Okay, welcome back. We'll try our first one. A, which is negative k over 4, is greater than negative 1. So this one, there's a couple of different ways you could do it. You could multiply by negative 4, or by positive 4, and then you'd have to divide by negative 1. Or you could just rewrite this so that the negative is right with the 4. And that might be a little bit shorter if we do it that way. Because now when I multiply by negative 4, I know right away I have to flip the sign, and I get k is less than negative 1 times negative 4 is positive 4. And again, I can put that one on a number line. I'll have 3, 4, 5, open circle at 4. It's less than, so I shade all this. And so I could check 3, and I could say, okay, is negative 3/4. Oh, you can see that. Is negative 3/4 greater than negative 1? And it is. That's true. So let's look at B now. So for B, you've got negative t is less than a half. So this is like negative 1t. So I'm going to divide by negative 1 here. And I'm dividing by a negative, so you have to flip the sign. So this becomes t is greater than negative half. T is greater than negative half. And then for C, we've got 6 is less than or equal to negative 3/5 w. So on this one, we're going to multiply both sides. Did we just do this one? Oh no, that was 3. By negative 5/3. I'm running out of room over here. I should have left more room. So these cancel, and I need to flip the sign. So I had negative 5/3 times 6/1. So negative 5 times 6 is negative 30. 3 times 1 is 3. So negative 30 divided by 3 is 10. So this is w is less than or equal to negative 10. And there's our answer. So on a number line, just to talk about this again, if I have negative 11, negative 10, negative 9, this would have been a closed circle, and its w is less than, so you should have gone to the right. And it's always a good idea to rewrite it so that the variable is leading. Okay, so that was on those ones. We were multiplying or dividing by negative. Let's look at another example, which is right here. Negative 4 is less than 24. No, negative 4c is less than 24. So this is negative 4 times c. So now I'm going to go ahead and divide both sides by negative 4. And I divided by a negative, so you have to flip the sign. 24 divided by negative 4 is negative 6. So on a number line, I have negative 7, negative 6, negative 5. So I have an open circle at negative 6, and its c is greater than negative 6. So I could check this by plugging negative 5 in up here. So I have negative 4 times negative 5, and is that less than 24? Well, is 20 less than 24? Yes. So we did it right. Okay, try quick check 3. This one is on page 214. There are 3 of them. Go ahead and hit play when you're ready. Okay, here's our first one. We've got negative 2t is less than negative 8. So I'm going to divide by negative 2, and I've just divided by a negative. So I got to flip the sign. T is greater than 4. So I will check this one because it's a good habit to get into for you guys. Good way to make sure you don't make any mistakes on any tests. So this would be an open circle at 4, and its t is greater than, so we shade to the right. So I can check and see if 5 really does work in here. So I would do negative 2 times 5 Is that less than negative 8? Well, that's negative 10, and negative 10 is less than negative 8, so I know I did it right. Okay, let's try B. Negative 3w is greater than or equal to 12, so I'm going to divide by negative 3. So flip the sign. W is less than or equal to negative 4. And last one, C. We've got 0.6 is greater than negative 0.2n. So you're going to divide by negative 0.2, divided by a negative, so you got to flip the sign. 0.6 divided by negative 0.2 is negative 3. I flip the sign. And again, I'd rewrite that. Read it as n is greater than negative 3. N is greater than negative 3. Okay, so that's it. Go back and rewatch any parts that you had questions on. Thanks for watching.